Unit 2 review is brought to you by a generous donation by Abstergo Industries, leading the world into a better tomorrow. And as always, viewers like you. All right, it's time for final review, Unit 2. So the first thing that we learned about here was how to write the equation of a line that goes through a point and has a slope. So if we have that, what we have to do is we actually have to find, remember it's y equals mx plus b. Well, we already have the m value, so I can already write 2x plus, and who knows what b is going to be. I'm going to leave a dot there. So at that point, we have a point actually up, so I'm going to plug in 3 equals 2. Wait, I also have an x value, so I'm going to say times -1 plus b. So I'm trying to find this out. So this becomes 3 equals -2 plus b. At which point I would add 2 to both sides, meaning 5 equals b. So I would go back up here and say plus 5. That's how we write an equation of a line if it goes through that point. Now, we're going to talk about the different types of system of equation answers we can have. The first is called inconsistent. That is when we have two lines that run parallel to each other to the point that they never touch. What we know is, well, then we have two types of consistent. But before we talk about that, let's go back to the inconsistent line. The inconsistent line, like I said, is two parallel lines that don't touch. Please notice that they have the same slope, but they have different y-intercepts. Now, consistent lines can either be independent or dependent. Independent lines are two lines that just touch at one point. They cross each other, they have different slopes, different y-intercepts possibly, but not guaranteed. Then we have dependent. Dependent lines end up looking like this. Where's the second line? Oh wait, there it is, hidden at the same spot as the first. So with independent lines, we have two lines that touch at one point. With dependent lines, it's important that you note that this is two lines. Okay, so let's talk briefly about the different types of lines. Inconsistent lines, like I said, are parallel. They have the same slope, but they have different y-intercepts. And no solutions. Independent lines, different slopes. They can have the same or different y-intercepts depending on where they touch. And there's one solution. Finally, dependent lines are the same line, meaning same slope, same y-intercept, and infinite solutions. Ooh. All right, so now we have to decide if these are independent, dependent, or inconsistent. So the way that we do this is very simple. We want to put both of these into y equals mode. So on the first one, this is easy. This just becomes y equals -3x plus 5. But on this one over here, what we end up having to do is first subtract the 15x, which means 5y equals -15x plus 2. Then, because I want to get everything to be equal to each other, I'm going to divide everything by 5 so that it all equals y. Y would equal -3x plus 2/5. Notice here, different y-intercept, same slope. That means that these two are inconsistent. They are parallel and they never touch. Okay, now we're going to talk about how to solve by graphing. So whenever I look at an equation that looks like this, if I want to solve by graphing, the first thing I do is I change my equation. So look at the original one. On y, I would subtract 2x. On the second one, add the x. So when I add them, I get this. First one I graph is the top one. That's the blue. Then I graph the bottom. That's the green. And you can see right here, the answer ends up being, which is at 1, 3. Now let's look at this equation. So the first thing I need to do is I need to move everything over. So I'm going to subtract 2x on the first and x on the second. Now you'll notice on the bottom it says negative y. So I have to multiply everything by negative 1. But look what happens to the inequality sign there. Magic! It's switched directions. So now that we have that, we have two less thans. So the first thing I'm going to do is I'm going to graph y is less than negative 2x plus 5. That ends up looking like this. Now I'm going to graph y is less than x plus 2. That looks like this, and our answer ends up being in the overlap area, which is right here. And so that would end up being our answer. And that is how we solve by graphing. And that's the end of Unit 2. Remember, the rest of the unit's links can be found either on my page or in the description, depending on when you're looking at this. Thank you very much.